This is for Year 11 methods. We're going to look at exercise 3.3, question number 7. So we've got a water fountain that forms a parabolic shape. If P is the horizontal distance from the water outlet and then height is given by here, and we know H and P are in centimeters, plot the graph of the relationship between H and P with P on the horizontal axis and between 0 to 80. Now, I'm not going to do that because that's going to take a lot of time, and frankly, on the tests, you won't have time to, plot something like this. What I will show you is how to do this on the CAS calculator. Okay, so we're going to plot it, but we're not going to plot it by hand. We're going to employ the help of our CAS calculator. So I'm going to clear all. I'm going to clear all here. What I'll do is enter the equation. So we've got -1 on 16. So we'll click the negative button, -1 divided by 16. Oops. X, so my P is like my X, minus 40 squared plus 100. Now I'm going to put this graph onto my CAS calculator and hopefully something shows up. Now, our window's too small, so I will have to enlarge. So I'll zoom out, keep zooming out until you get appropriate. Okay, good. We've got our fountain. Okay, so we'll need some key features. So let's find our x-intercept. So we'll find where our roots is 0, 0, and 80, 0. Okay. So if I were to draw the graph, so this is, you have to label your axis. This is your height in meters, and this is your P. Oh, that's in centimeters. Sorry, that's P in centimeters. So you've got a shape that looks like this. It's parabolic. That's 0. That's 80. So I've labelled both my x-intercepts, and my turning point, if I refer to the graph, is at, I'll have to go analysis, G-solve, and maximum. So 40, 100 is my turning point. So this place is 40, 100. Okay. So I've plotted the graph. I've labelled my axes. Okay, that's all I need to do. That's part A done. How high does the water go up the air? Okay, we can see that our maximum point is 40, 100. 40 represents the horizontal distance, 100 represents the vertical distance. So 100 meters would be the highest it could go. How far across from the water does how far across from the water outlet does the water from the fountain reach? Okay, so we can see it can reach up to 80 centimeters. So how far across? It will be 80 centimeters because that's the maximum where it drops back down. If the fountain starts at the center of the circular pool and reaches the edge of the pool, what is the surface area of the pool? Okay, so we've got this scenario. The fountain is going like this. The distance between here and here is 80. Okay, so that's my radius. My radius is 80. So we're trying to find the surface area of the pool, which is here. What's that area? It's the area of a circle, essentially. So we've got a circle, and the radius is 80. Okay, so the surface area, the area of a circle is pi r squared, pi 80 squared. That should give me the answer. So let's work that out on our CAS calculator. Pi 80 squared. So I'm going to get rid of this. Pi 80 squared. So we get 201.06. 201.06. 201.06 centimeters squared. Okay. Also put your units. So that's basically how you approach a question like this. The only difference I didn't actually plot on. I just used my CAS calculator to help me calculate this, because a question like this would most likely be a calculator type question. So you don't have to worry about plotting something that's a bit. It's not very nice to plot because you have to sub in quite a lot of values in. So hopefully, going to give you an idea of how to approach this problem.